Hello everyone, welcome to my YouTube channel Self Skill Education and Learning Forum. In this video, we are going to discuss heat treatment of metals, its types, process, and applications. So, the first question is, what is heat treatment? It is heating and cooling of metals at controlled rate to get desired improvement in mechanical properties. So first of all, let us see purpose of heat treatment. Heat treatment is used to increase mechanical properties like ductility, strength, toughness of metals. It is also used to increase machinability. Generally, in cold working, internal stresses are developed. To relieve these internal stresses, heat treatment is done after cold working. It is also used to improve properties like corrosion resistance and hardness. Let us see the process of heat treatment. It consists of three steps. First, the metal is heated to a specific temperature and it is kept at that temperature for a specific period of time. In this time, the material rearranges its grain structure depending upon the temperature, and after that material is cooled at specific rate so as to get the desired improvement in its properties. Let us see what are the types of heat treatments. There are five types of heat treatments: annealing, normalizing, hardening, tempering, and case hardening. Case hardening can be done in four ways: case carburizing, cyaniding, nitriding, and flame hardening. Let us see the temperature range for heat treatments. In this slide, you can see this is the range for normalizing, and this is the range for annealing. In annealing and normalizing, the material is heated above its critical temperature. Also, you can see this is the range for hardening, and tempering is done below critical temperature, and the temperature range can be seen in the diagram. Let us see the heat treatments one by one. First one is annealing. In annealing, material is heated 20 degrees Celsius above its critical temperature. Then it is allowed to soak at that temperature for around 1 to 2 hours, and then it is cooled very slowly at about 100 degrees Celsius per hour so that the material rearrange its grain structure and releases residual stresses while cooling. In steels, at the end of cooling, we will get ferrite or perlite. Purpose of annealing. Annealing is used to relieve internal stresses and refine grain structure. It is also used to increase ductility, toughness, and machinability. In simple words, annealing is used to soften the material. Next is normalizing. Normalizing is done by heating the material 40 to 50 degrees Celsius above its critical temperature. Then it is held at that temperature for around 15 minutes and then it is cooled slowly. Normalizing is done on cold work parts to remove internal stresses and restructure the material grain. The temperature range for normalizing can be seen in the figure. Purpose of normalizing. It is used to eliminate internal stresses. It is also used to increase strength. Normalizing is done at higher temperature than annealing, and the ductility obtained in normalizing is somewhat lower. Hardening. It is process of heating steel to temperature above critical temperature, then holding it to that temperature for specific time, and very importantly quenching it. Quenching is dipping the material directly into the bath of oil, water, or polymer. As the name implies, hardening is used to increase hardness. Depending on the temperature of heating and rate of quenching, mechanical properties like strength, toughness, and elasticity are varied. Next is tempering. Tempering is done after hardening. Hence, we call it as hardening and tempering. Tempering is done to release internal stresses produced due to rapid cooling in hardening process. In tempering, the part is reheated to a temperature less than hardening temperature and it is holded at that temperature for some time and cooled slowly. You can see the temperature tempering range in the figure. The purpose of tempering is reducing internal stresses produced due to hardening. It is also used to restore ductility, toughness, and shock resistance. The next is case hardening. It is also called as surface hardening. Surface hardening is used to harden the surface. Case carburizing. In case carburizing, mild steels are heated near its critical temperature with charcoal or carbon around its surface. At such high temperature, carbon form metal solution in iron and the surface becomes high carbon steel. High carbon steel is hard and there is tough core of mild steel inside. Next is cyaniding. In this process, steel is immersed in bath of sodium chloride, sodium carbonate, and sodium cyanide at a temperature of 800 to 900 degrees Celsius. And then it is dipped in cold bath for quenching. The case hardening in this process is uniform and we can get great surface finish. Next is nitriding. In nitriding, steel is heated above 500 degrees Celsius in presence of ammonia. This forms nitrides on surface. Nitrides are hard in nature, which forms which increase the hardness of surface. Next is flame hardening. As the name suggests, the surface is heated by flame. In this process, the surface which required to harden is heated by oxyacetylene flame and it is quenched. This process is quick process and part of completed material can be hardened only. It means if a specific part of surface is required to be hardened, then this method is more preferable. Summary. Heat treatments are done to improve mechanical properties like ductility, toughness, etc. Case hardening is required to reduce surface wear of parts without losing core toughness. And we can find applications of heat treatment in sectors like automobile, aeroplanes, and hydraulic parts. Also, pump parts, its shaft, various gauges, dies are also heat treated. So these are the applications of heat treatment. That's it. If you have any query regarding this video, please comment in the comment section below. If you like this video, please press the like button and don't forget to subscribe my channel. Thank you. Thanks a lot.